In this problem, this is example 2 of the definition of derivative. We'd like to find f prime of x, given that f of x equals 4x. And we'd like to do this by the definition of the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. So when I substitute x plus h into f of x, I'll still have the limit as h goes to 0, because I haven't taken the limit yet. And this will be 4 times x plus h minus f of x, which is 4x, all over h. And when I simplify this, I'll have the limit as h goes to 0. This will be 4x plus 4h minus 4x all over h. The 4x's will subtract out, and we'll be left with the limit as h goes to 0 of 4h over h, which would just reduce down to 4. And when I substitute 0 in for h into 4, I'm left with just 4. Which means that we've just shown that f prime of x equals 4 by the definition of the derivative if f of x is 4x. Let's do example 3. So in example 3, we are told that f of x equals x squared plus x, and we'd like to find f prime of x by the definition of the derivative of the limit as h goes to 0 of f of x plus h minus f of x all over h. When I substitute in, I'll still have the limit as h goes to 0 because I haven't taken the limit yet. And I'll have x plus h squared plus x plus h, that's f of x plus h, minus x squared plus x all over h. Kind of an ugly looking thing, but nevertheless, as we keep simplifying, we'll have the limit as h goes to 0 still. X plus h quantity squared is x squared plus 2hx plus h squared plus x plus h minus x squared minus x. And this will all be over h. Simplifying further, we've got the limit as h goes to 0. The x squareds will subtract out and the x's will subtract out. So we will have 2hx plus h squared plus h. And that whole expression is still being divided by h, which is nice because now when we divide everything by h, we're left with 2x plus h. And the limit of this when h is 0 can be solved by substitution. We're left with 2x plus 0, which is just 2x. Which means that in this case, f prime of x equals 2x by the definition of the derivative. Now, on this question, someone could follow up and just want to know, what is f prime of 5? Well, once we've found the derivative, like we did here, then all we're doing is substituting 5 in for x in the derivative. In this case, it would be 2 times 5, or just 10. So there are a few more examples of how to find the derivative of a function by the definition of the derivative, the limit definition, and how to evaluate the derivative at a specific x value.